Okay, I'll be recording this particular session so you can also view it later. Right. Now, as we know, paper 5, the total mark for paper 5 is 30 marks. So we have question 1 and question 2, which carries 30 marks. Okay, that means question 1 15 marks, question 2 is also 15 marks. Okay, so for today's seminar, I'll be explaining about question 1, right? Because among these two questions, question 1 is the most challenging question, where students find it difficult to score very high mark in question 1. Question 2, by practice, you should able to score. Okay, so for question 1, so what we are going to look at is the technique of answering. How do you answer the question 1, right? How do you able to use what I call table method, where you can draw a simple table and write down the important points, and it becomes like a checklist, so that you have all the important points for you to write on. Okay, now if you look at the format of the paper, right? Okay, if you look at the format of the paper, you have the question, right? And then you have the diagram here on page 3. And then you have 1.5 pages where you're supposed to write the workings and answers and whatever not. So normally students, when they start with paper, this particular paper or this particular question, okay, normally students will start to draw, right? Do that. You don't start with the drawing, right? I'll tell you why. You don't start drawing because once you start drawing, and then what you write, and later on you might find that your drawing may not reflect to what you have written there, or vice versa, then that may not give a very good impression, right? So we don't want that. So drawing should be the last, right? So I'll teach you the techniques first. How do you go about it, right? Okay, so assuming that you be given scribbling paper in when you're doing this paper 5, okay, you can use this method. You can draw a simple table, but not on this paper, because this paper you have to submit to Cambridge. Don't draw the table here. Okay, so you draw on the scribbling paper, right? And I'll show you how to go about it. Okay, so I hope you took the screenshot of this or photograph of this, so because I'll be closing this particular window. Okay, so let's say now you have a scribbling paper. Okay, so you have a scribbling paper. What you need to do on the scribbling paper, okay, so we need to draw a simple table. Okay, so we have the variables, right? So we have the variables, and then we have 3 variables, right? Which is the independent. Okay, we have the independent, we have the dependent, right? And the constant. Okay, normally when we talk about constant, right, we only list one constant, right? Okay, in any experiment, there actually more than one constant. Okay, let's say there are three constant, right? Let's just put three constant first, right? So we have variables, then we have the procedures. This procedure can be divided into two. One is the measuring tools, okay, and the other one is the measuring technique, right? And then we have the additional details, okay, and then we have the analysis, and lastly is the safety. Okay, so I'm going to draw all these like this, right? You know why later. So there's no necessary you have to draw the table exactly like this, okay? Right? After you practice few times, you can just jot down the points that I've written here, right? But if you able to draw this table, which will take less than 1 minute, that will be great. Now, if you look at the mark scheme, right? How the marks or how the marks are awarded, right? They use a particular code. Mark scheme, they normally use code. Like for example, if you look at the structure paper, paper 2 or um, paper 4, they will normally use codes like A for answer, B for like definition, M for method, and so on. So the same thing that they use in this paper 5. Okay, like variables, they will use the letter P. Okay, P. So for this particular mark scheme, for this particular question, right, which I showed you earlier here, this is um, October, November 2018, paper 5.1. So it is given 2 marks for this. Okay, 2 marks. And then the method is given only 4 marks, right? They go for but using the letter M, that's for method, right? Analysis 3 marks, A, right? So how many marks altogether? 4, 5, 6, 7, 8, 9, right? And the rest of the mark actually go for analysis, where they put, sorry, not analysis is 3 mark. The rest of the mark goes for additional detail, where they give about 6 marks here, right? That means most of the mark goes for additional detail, where most students, this is where most students will lose mark. Okay, this is where most students tend to lose mark, additional detail, right? Because the main concentration of student is only on the procedure. Okay, you are too focused drawing the diagram, you are too focused writing the procedure, okay, right? And then you don't write many points for additional detail, right? And then some of the students also spend a lot of time writing safety precautions, right? So these are the things that I noticed over the years when I mark the paper 5, right? Why students are losing mark, right? Because of this. Right. Okay, now you have this all these written. Okay. Let's say now you have draw the diagram table. You have wrote all these points here. Okay. This shouldn't take more than 1 minute. Just a simple table will do, right? So if you look at it, there are many vacant place here. You have to fill up. So as you fill up, you have many points to write on, especially analysis. Analysis is where where you can score easy mark, right? So we will start with analysis first, right? So when you're going to start doing paper question 1 on paper 5, you start with analysis first, right? Right. Then once you're done with analysis, then you do the variables, independent, dependent, constant. Okay, this is what I want you to do. Okay, now I hope you have filled up, you have drawn the table. So I give you 1 or 2 minutes for you to draw your own table. You follow the table here, right? Can you do that now? If you have done drawing the table, please type done in the chat so I know that you have done. Okay, so I think most of you all done. All right. Okay, let's look at the question. The question now says that a student is investigating how the boiling point of a salt solution varies with pressure. Okay, so it's suggested that the relationship between the Celsius temperature of theta at which the water of the solution starts to boil and the air pressure is given by the formula theta K sigma PQ, right? So you're given this particular equation. Theta is the density, right? No, sigma is the density, and K and Q are the constants. Design a laboratory experiment to test the relationship between theta and P, okay, the temperature and the pressure, and then how would you determine the K and Q? Okay, so that's the question. Most of the time, the question given is out of your knowledge of physics practical that you have done. Okay, or maybe the concept is not really related to the core syllabus. Like example like this, maybe we have not done this experiment, but that's the whole idea. Okay, so something that maybe something is newer, but this is not for you to go and think about it and you try to figure out, have I done this experiment before? Have the teacher have discussed this experiment before? You're actually wasting time, right? So rather than doing that, the first thing you should do, right, you write down the formula. That means I told you we're going to do the analysis first. This is the first thing we have to do. And the second thing, we do the variable, right? Then we do the procedures. Then only we do the analysis, right? Why we do the analysis? Because this is straightforward, okay? Not only that, from the analysis, we are able to identify the independent and dependent variables. So if you look at this particular formula, this is not, it's a non-linear formula. So you have to change into a linear equation. So how do we do that? We use log. Okay, so log log theta equals to what? How do we change these? So we have Q log P plus log K sigma. I'm going to just write like that. Okay. So you can put it that way. You can put it this way. So that means we use the log. So now you compare the equation you have written to y equals to mx plus c. Okay, because it's now a linear equation. This was a non-linear. We changed to a linear equation. So when we change to linear equation, we compare with y equals to mx plus c. So here we can identify that the y is the log theta, x is log p, okay, the gradient is q, and y-intercept is log k sigma. Okay, so this is how we identify. So more or less now you're able to identify the independent and dependent already, and then the constants also you are able to identify, right? Okay, so the next thing what you should do, okay, what is the expected graph? What would be the expected graph? Because now since you compare the y equals to mx plus c with this equation, what will be the expected graph? So if I plot log theta versus log p, okay, so I would get this graph. This is the expected graph. You no need to put values and so on, all right? Just draw the expected graph. That means if this experiment is conducted according to the procedure that you have written, the instruction that you have written, right? This is the graph that can be obtained from the results from this experiment. Okay. Then once you have done this graph, okay, how do we analyze the graph? So from the graph, the gradient is q, the y-intercept. Okay, the y-intercept is log k sigma. Okay, so write that gradient, must write gradient q, y-intercept is log k theta. Okay, k sigma. All right. Okay. So what else? What else we need to do? Question says you need to find out the value of k. So y-intercept. All right. I'm going to put c here. Log k sigma. So this becomes tan c. The y-intercept tan c. And this is k sigma. So k equals to tan c over the sigma. Okay, so I do that because the question asks you to find out k and then asks you to find out q, isn't it? So I have done all these, and the last is that why are we doing this? Okay, what is the reason we do this? Is to verify the experiment or the relationship, because the question says that how do you design a laboratory experiment to test the relationship between theta and p. Okay, so if you're going to test the relationship given, if you're going to test the relationship given, then you must able to explain how that the particular experiment, whether it's able to verify the relationship or not. So a simple statement would do. So relationship is valid. Okay. relationship is valid, right? Relationship is valid if a straight line is obtained, right? So this is a statement that you have to write under the analysis, where it shows that if the above graph is obtained, then that particular experiment can be verified. Okay, so how many marks do you score here? How many marks you score? I put here 3 marks, correct? So if you plot the graph, you score A1, that's for analysis, right? If you state the gradient here, you score A1 mark, another 1 mark. And if you say that K is this, right? Because they ask you to find out the K, this is A1, isn't it? So this is 3 marks according to the analysis, right? Now, under additional detail, you will score 1 mark here, and you score another 1 mark here because you are changing this equation to here. This you will score another 1 mark, right? So overall, if you do this under analysis, you don't only score the mark for the analysis, you also score the marks for the additional detail, right? And analysis is straightforward, right? It gives you an idea what is it about, what is the whole experiment about. Okay, you must try to understand the whole physics concept, all right, of trying to apply or trying to prove a theory, right? First, we have to do mathematical analysis of a particular theory. Then we have to do a simulation on an experiment to prove whether the theory is correct or not. So what you're doing is that sequence. You are writing the mathematical proving and also trying to show the relationship between one physical quantity to the other. In this case, is the independent and dependent. Then only you can come up with the procedures, variables, and whatever not. So that is how you approach this particular question. Okay. Now, when you do this, the beginning stage, of course, this is going to take more than 1 hour. But by practice, after you practice these few times, right, you may find out that you no need to draw this table like how I've shown you here. Okay, you can simply just sketch simple points, but make sure you have all these points. Okay. Okay, the next procedure. Okay, so once we have identified the graph, the gradient, y-intercept, so more or less we can now identify the dependent and independent. Okay, so in this case, independent would be the P. So the pressure will be the independent, right? And dependent will be the temperature, theta. Okay, that will be that, these two lah. Okay, so what are the constants here? So here the main constant would be theta, because this is from the gradient, right? If you look at, from the y-intercept, because we do not know what is Q and K. They didn't say what is Q and K. They only say that theta, sigma, here is the density. So therefore density of the solution. Okay, so when we talk about density, we can look into the formula. Density is mass over volume. Straight away we can think about the formula involved and whatever not. Okay, so what are other constants we need to have? Is there any other constants? Right, think about, is there like do you need to make any other physical quantities, or maybe the boiling point, because they say start to boil, boiling point, isn't it? Because the question says that the temperature of the salt solution where it will start to boil. Okay, it will start to boil. So the boiling point is important. Okay, that will be a constant, but that is not the main constant. The density is the main constant. Okay, okay. So is there any other constants? All right, never mind. Let's see whether there's any other constant. No. Okay. So once we have identified these, now we can look at the measuring tool. So what is the appropriate measuring tool? Make sure that the tool is something that you can find in the physics lab. It's not something that you saw in the movie, okay, or something that you can find in Dexter's laboratory. No, okay, something which is accessible in a college or school laboratory, right? So, what would be the best tool to measure the pressure? Uh, or how do we and what is the tool to measure the temperature? Temperature is given must be in degrees Celsius because the question says it must be in degrees Celsius. Okay, so the best tool would be, of course, pressure gauge lah. So pressure gauge you can use burden gauge. Burden gauge, okay, or if you're not sure about the name, just name it as pressure gauge. That will be is good enough. Another thing you can use is manometer. All right, so manometer, the one look like a U-shaped tube, right? You can use a manometer, but this you have to make sure that whether this manometer can be used for the experiment or not. All right, if the pressure gauge is the most easiest, right? So what is the pressure gauge or burden gauge? Next time you go to college, look for the fire extinguisher. You see like a round shape on top of the fire extinguisher, which is showing some reading. That is the pressure gauge, right? So at least you are able to picture what is it about, right? So that will be the best tool for this. Okay. So what is the measuring technique for this? Do you have a particular measuring technique? Uh, is there a way to, um, for example, okay, it's we need to change the value of the pressure, correct or not? So we need to change the value of pressure. So how do we going to do that? How are we going to change the value of the pressure? So you have to ask yourself whether are you going to increase the pressure or decrease the pressure. Okay, if you're going to increase the pressure, then you need to use a pump. Okay, if you're going to decrease the pressure, then we're going to use a vacuum pump, right? So this will increase the pressure, this will decrease the pressure. Okay, so this is something you have to explain, right? Measuring technique, how do you change the pressure, whether you want to increase or decrease, and what will be the best tool. All right, so if you're going to increase, then you have to use an air pump. If you're going to decrease, then you have to use a vacuum. Right, so that must be explained. Right, this also goes into the additional detail as well as safety. For example, if you're going to use if you're going to use some sort of pump or vacuum pump, then you have to also look into the safety feature, right? So that you don't use very high value or low value, okay? That because may damage the experiment if it's in a chamber. For example, if you're going to put inside a chamber and here is going to be a pump or vacuum pump, right? Here is going to be the pressure gauge, right? Very simple drawing, not two-dimensional drawing. And this chamber is going to be made of whether it's a plastic or whether it's going to be a glass, then you need to know that the very high pressure or low pressure may break, right? So that considered as a safety precaution, right? Maybe you need to have a safety screen, right? You are standing here, so this is a safety screen. You have to apply a safety screen to protect yourself from the experiment. So this is the some sort of example. Okay. So the next thing is also about what are the additional details when we talk about pressure changes. The pressure cannot be changed, all right, very fast. You have to change it very slowly. I'm going to write here slow change of pressure. Okay, slow increase or decrease of pressure. So this is also important. This all comes in under additional details, right? So you can include this. Why I include safety here? Because there's no separate mark for safety, right? There's mark, the safety comes under additional detail. Okay, all right. So far, any question? Any question? Okay, let's move on if there's no question. The next question is about the dependent. So now the dependent is the temperature. Okay, what would be the measuring tool to measure the temperature? So we have learned thermometers, right, in the topic in thermophysics, right? So there are many type of thermometers, thermocouple thermometer, okay, and then you have resistance thermometer, you have liquid in glass thermometer, and the other one is what, constant pressure gas thermometer. Okay, now we have to choose the one appropriate. So over here the question is quite clear that we are going to use the water and water solution, water salt solution, and it must be in Celsius temperature. So the best thermometer is basically the liquid in glass thermometer lah, thermometer, or what we call as the laboratory thermometer, right? Because laboratory thermometer, the one of course you see is up to 100, but there are thermometers where you can go measure more than 100 and it's a salt solution. So you're going to use a laboratory thermometer. All right, that's straightforward. So the next question is that how do we going to, this is number one. Number two, how are we going to change the temperature? Okay, how are we going to change the temperature? So the best way of using is a hot plate, right? Hot plate or electrical heater. Now most of y'all might want to use a Bunsen burner. Okay, now if you are using a Bunsen burner, it's difficult to control the temperature, meaning that the flame is very difficult to control the temperature. But hot plate or electrical heater you can control. Like electrical heater, you can control the voltage, the current, right? So this is very important because when you're talking about slow change of pressure, right, we also need to look into the temperature changes, so we able to control it easily. Okay, so this is the best. Whenever there's a heating experiment, try to always go for hot plate, electrical heater, and so on. And then we're going to use thermometer lah. All right, so what are the measuring technique in this case? So whenever there's a heating involved, right, always we have to have some sort of safety precaution, right? So we have to use protective glove or heat resist resistance glove. Okay, this is another thing where I notice when I mark students' paper, right? When students say use glove, there are many type of gloves. Okay, the normal glove. Okay, nowadays people use the rubber glove. Can you use it for to handle these hot things or not? If you're going to touch the hot object with the rubber glove, the glove is now going to be part of your hand. Okay, it's going to attach to your hand, and that's it. All right, you're going to be a rubber man or rubber lady. All right, so that is not a good idea. All right, that may not give you. That will now, if the examiner marks wrong, or they might give a benefit of doubt. That means possibility of you not getting marked for that is very high. Now, what are the type of gloves that you have? This is heat resistive glove. Okay, if you are handling sharp object, like in paper 5 question 1, there are questions where you might have to handle glass, okay, glass object, or like example wire. So these are the things which is sharp, it may cut your hand. That you can't use a heat resistive glove, or you can't use a rubber glove. Okay, it's going to cut through the rubber glove. Okay, so what you need to use, what is the name of that particular glove? Any idea? Anyone have the name or the term for that glove? What do you call that? What glove is that? Anyone like to answer that? Maybe you can go and Google it, find out what you call the glove which can prevent you from getting cut. Welding glove. Welding glove. Welding glove is when you're using, that's more on like a heat resistive. Hmm? Well, very simple guys. You see, gloves that protect you from heat is called heat resistive glove. So glove that prevents you from getting cut is just put cut resistive glove. Okay, that's it. Or just describe the glove. Glove that can resist cut or prevent cut. Okay. All right. How about if you are handling radioactive material? You have to hold if you if you have to hold the radioactive material with your hand, what glove would you use? Rubber glove is not going to work. You're still going to get radiated. Heat resistance also cannot. Cut resistance glove also cannot. The radiation is still going to be absorbed by your hand. So what do you call that glove? Any idea or not? Lead glove, very good. Yes. All right, lead glove. And the glove has a lead lining. So that can lead, because lead, as you know, prevents uh, the radiation. So alpha, beta, and most of what we call low energy gamma can prevent. So we use the lead glove. So be specific, right? To score mark, right, and prevent you from scoring benefit or doubt mark. All right, we don't want that benefit or doubt. We don't want, because 15 marks is very less, right? So the examiner is going to be very particular in awarding mark, right? So if let's say now he or she feels that you're not very specific, you can give a better answer, they're not going to give you that mark, right? Okay, let's move on. So we have done all that. Okay, How about now the um, density? We need to find the, do we need to find the density? Okay, density of the salt solution. Yes, we use this particular formula, right? So if you are using this particular formula, then we need to make sure that we measure the mass, right, and volume. So how do we do that? We're using electronic balance, volume using a cylinder, right? All this explain lah. This is where you can score the additional mark. Okay. All right. What else? What else that we can add? What else we can add to this? The question says something about boiling point, right? Something about boiling point. How do we know that the object has reached a boiling point? Because we are going to find the temperature of the boiling point. For water, the boiling point is 100. Okay, so how do we identify the boiling point? How do we identify the boiling point? If for water, we know water, pure water boils at 100 degrees Celsius. Fine. Salt solution is going to change the boiling point. That is the whole idea. Temperature curve. We already have this graph here. From the experiment through observation. When you're doing the experiment, you have to use, all right, your instinct, your observation, your eyes, sense of sight, hearing, smell, all these you have to use to make an observation. So what is the observation that in this experiment for a boiling point? How do you know the salt is boiling? What you observe, what do you see when something is boiling? Any idea? Very good. You see bubbles. Okay, you see bubbles, right? Vapor and bubble, right? You see these. This is the observation, right? So you talk about this boiling point is important. So when you talk about the boiling point, you're scoring the additional detail marks. Okay, don't leave it alone because you have listed out all these. You must mention something about all these. Okay, to score the additional mark, right? Okay, what else? Anything else or not from the experiment? Anything else from the experiment? All right, so these are the main concept of the experiment. Right. Okay, so we have more or less we have written, right? We have filled up these. Okay, we have wrote the tools, measuring tool, additional detail including the safety. Okay, we have identified tool to measure, tool to control the pressure. Okay, we have explained the measuring tool for the temperature. How do we control the temperature? Okay, we explain here. And then the safety precautions. How do we now safeguard ourselves because we are dealing with hot substance here. Okay, and then under constant, we explain about the formula involved. How do we measure the mass, the volume, whatever not, the boiling point? How do we identify the boiling point? Okay, so how many marks you think you're going to score here? Now, for this, most of the mark scheme for the last 3-4 years, they are giving only 1 mark. Okay, it's very sad, but that is the truth. independent and dependent. They're only giving one mark. Okay, that means one of it is wrong, gone. All right. Constant over here is only one mark. So that means for you to identify the independent and dependent, you score one mark. For you to identify the constant, you score one mark. Okay, so P2 is done. Here's 4 marks. So how's the marks are awarded? Okay, if you look at that, if you look at the procedure, right? So if you write the procedure accordingly, of course, the 1 mark goes for the diagram. Okay, we'll come to that later. Diagram is the last, right? Most students are very excited to draw the diagram. Okay, I call this the kindergarten syndrome. The moment you give them blank page, do the experiment, they start drawing the diagram. Okay, so don't do that. Okay, start writing first. I'll tell you why. Okay, so how do you score the marks here? So you have the measuring tool, the technique. Okay, diagram 1 mark. That means you're only left with 3 marks for the procedure. Okay, so here you get identifying the tool, right? So you get 1 mark. Identifying the tool, you get 1 mark. Okay, using thermometer, you score 1 mark, right? And then how do you control the temperature, you score 1 mark, right? So this is how the marks are awarded. All these will come under additional detail. Okay, so how about in additional detail, what do you score? Right, if you use safety precaution in this case, you're using a safety screen to protect yourself from the changing the pressure, maybe it will break. So here you score 1 mark, right? If you use these protective heat resistant glove, you score 1 mark. Okay, right. Slow change of pressure, okay, you score 1 mark, right? Using this particular formula to find the density of the salt solution, you score 1 mark. Okay, so these are the main the marks that you are scoring. And then the other one, how to identify, okay, you score another mark. So here you already have 1, 2, 3, 4, 5, and not including here, this one you already have another 2 marks here. Okay, so you have all these points now. All right, now obviously it's going to take some time for you to write, but okay, you can write short, you can write in a point, simple points. At least you can, when you're writing, you have the points to elaborate. You can write as a sentence. Okay, any question? So after this, what you have to do? What do you do after this? You have the points, all the points is written here. What do you need to do? The next part. Anyone? Construct table, done, ready. What table? This table, we have done the table. There's no table, there's no need to draw a table in your explanation. Like what you did in paper 3, like example, pressure, temperature, and then log P, log Q. This one no need. There's no need for you to do that. Okay, there's no need for you to draw the table. All right. Okay, so what you need to do after this is basically you have to start writing. This is another main concern by student. You have the concern, how do I start writing? What format do I need to follow? Okay, do I write in paragraph format? Do I write in point format? If I'm going to write point format, okay, do I need to put numbers or do I put bullets? Why can't I use different bullets? Do I have to use this bullet? Okay, or do I put numerical? Do I need to put all these numbers, bullets? What bullet do I choose? Or do I put A, B, C, D? Do I put big A, big D? Right? All these is irrelevant. You just start writing. Okay? You just start writing. There's no time for you to think about the format and so on. Now, you can follow a very simple technique. You can follow this way. Okay? You start with this. You introduce the independent pressure. What is the independent pressure? Then you move on to this. Okay? Then you explain this way. You follow this method. You follow this arrow. You explain, explain, explain. Right? Each of these is one sentence. One sentence. You want to put it in paragraph, up to you. Right? You want to put it in point system, up to you. Right? The examiner is not bothered about the format. How are they going to mark? They're going to read your sentence, and if that sentence is classified under, say, under variable, for example, independent pressure is P. Okay, so independent variable is pressure P. Okay, so the examiner is going to mark, oh, P1, like that. Okay, and somewhere along the line you say, all right, how do we know the salt solution is boiling? All right, so we have to observe that once the salt solution start to boil, the observation is you can start to see bubbles are formed. Okay, so that the examiner will write D1 like that. Okay, this is how the examiner will label your answer. They're not going to look at format. What is the format? There's no particular format. You can write as whichever way that suitable for you, right? Then the next one, you move on to these, okay, and then you explain and so on. Okay, move on and then you explain. So this will take up at least this whole page here, and probably a quarter to here. Okay, up to quarter of page 4, the next page. Then you can start writing the analysis. Draw the graph. A lot of students have this notion in their mind that you cannot draw here. Okay, you cannot draw here because it's all lines. I only draw on the blank page. Okay, because that's how you are trained maybe in kindergarten or whatever. No, you can draw here also. You can in fact draw what you example, this particular safety, what I've drawn here. You can actually draw it out when you're explaining about the safety feature. Right? That's not a problem, right? So then you start explaining here the analysis, right? At the end, you can write the safety if you miss out anything, right? That's how that's the whole thing. How do you write the points and whatever not? Okay, now once you have done all these, then you start to draw the diagram. Okay, all right, why? Okay, when you start to draw the diagram after you wrote all the points, right? Okay, make sure you have 1 or 2 lines here left out. If no means no, it's okay, never mind. I'll tell you why. So once you have draw the diagram, everything, your diagram now reflects on what you have written. Okay, so that will now the diagram will have it give an impression to the examiner, because when the moment the examiner look at the diagram, the impression that the examiner must get is that this particular experimental setup that's shown on the diagram is workable. All right, the experiment must be workable. right? So whatever you have explained, right, must be reflected on the diagram, number one. Number two, as you draw the diagram, okay, as you draw the diagram, you might also think about, okay, the experimental setup, because you are, when you're drawing, you are thinking, you are trying to imagine how the experiment is going to be set up and be conducted, and you might have some points left out. That's the reason why I asked you to leave some blank space here for you to write certain statement. For example, you might forget, okay, that when you are putting the salt solution in the box, okay, when you're putting the salt solution in the box and you're heating up, okay, so this is the box here. You have the pump, whether it's vacuum pump or whatever. Then you have the pressure gauge, okay. Very simple, you just draw like these boxes, circles, and whatever you label here, that is done. You no need to draw the actual thing, pressure gauge, okay. So this is the salt solution, so this is the beaker, and this is going to be the hot plate, okay, and connected to a power supply. That's it, simple. Okay, while you're drawing these, suddenly you might think, wait, this is a container. This is a container. There's a like an opening here for the pressure gauge. There's another opening here for the vacuum pump. Wires to have to go in. That means this particular um, container must be sealed, because you are going to use the vacuum pump, or you're going to use the pump, so it must be properly sealed. Suddenly this idea came about. So what do you need to do? Just add the statement below here. That will do. You no need to go back and cut here and cut there, or use liquid paper, and you're not supposed to use correction tape or liquid paper, okay. So you just add the point here. That's all, right? It's straightforward. So you have all these points written, right? So you are able to score nothing less than 10, right? Which what most students they score less than 10, because they are not writing enough points. So with all these points, all right, that you have written, so you should able to score more than 10, right? Now, obviously, for the first time, it's going to take, okay, it's going to take more than half an hour just to draw this particular table, right? So by practice, you should able to uh, draw it out. Now, in an event that you did not get extra paper or scribbling paper, right? Just in case if there's a change in the exam rules and regulation, you can always draw a simple table here, right, in the space given. You can always draw it out here, right, but don't make it very obvious. Don't draw with a ruler and so on. Just draw simple, right? Just write down the points, variable, measuring tools, measuring technique, analysis, and so on, or I call it as a skeleton table, right? And once you finish the experiment, just cross it, show that you're canceling this particular information. All right, that's fine, it's okay. The examiner is going to look at only this particular page. Okay, any question for about what I've explained? We're not going to discuss question 2, because my main concern always is being question 1, and question 1 is where most of the students don't score very high mark. Question 2 you should be able to score where if you practice enough question, right? Anything you like to ask? Question? Please type it out if you have any question. Anyone have any other questions to ask? Okay, if there's no question, that's all I have for this particular paper. All right, like what I told you, for today is the discussion is about question one. How do you solve? How do you use the best answering technique or the most effective answering technique to score or to write the more all the important points for you to get the most of the mark. Okay, so if we use this particular method which I've been teaching my student over the years, and most of them say that they have benefited, right, from this particular table. So as long you have fill up this table with all the points, you should able to have enough points to write, or else you might see that only very less points you have, and that may not be good because you might not score. And this is actually a scoring paper, right? You can score uh, near to about maybe 30, okay, if it's not, maybe about 25 marks, all right? Because question 2 you can score more or less about 12 to 13, and here you can score at least another 12 or 13, so you can get more than 25 marks. Okay, right? Most of the students score less than 10 marks. On average they score about 7 to 9 marks because of all this. Okay, so you want the notes? Ken, I'll send you the notes. Anyone have any other question, guys? Anything you want to ask? If no, then those who have question can stay behind.